All right, let's take a look at this question. This is from a Waves paper, and it says it's about pan flutes. We're given the speed of sound in air, and we're told that a pan flute is made of pipes that are closed at one end. Maria produces different frequency notes by blowing air across the top of different pipes. And she is producing the fundamental frequency in a pipe, and we're asked to draw the standing wave that Maria is producing. The fundamental or first harmonic. Okay, so the pipe closed at one end, open at the other. So the first harmonic is when we have a node and an antinode, and we fit in exactly a quarter wavelength into the pipe. And this is the antinode, and this is the node. Okay, we've done everything we need in that question. Maria then blows across one pipe, and a fundamental frequency of 350 Hz is produced, and a second pipe produces a fundamental frequency of 395 Hz. So 350 and 395. Explain which pipe is longer. Okay, so the longer pipe is going to have a longer quarter wavelength in it, so it's going to have a longer wavelength for the first harmonic. The longer wavelength, because the wavelength is 4 times the length of the pipe. Okay, so if the wavelength is longer, then the frequency is going to be lower, because the frequency is the speed of sound divided by the wavelength. And so the lower frequency one must be the longer pipe. Okay, so let's summarize that. So the longer pipe will have a longer wavelength. As lambda is equal to 4L. Okay, so that was our first point here. Let's just make that less messy. The second point that we want to make is this pipe will have the lower frequency because F is equal to V over lambda. This pipe will have the lower frequency as F is equal to V over lambda, and V is constant. That we were told that was 343 meters per second. Thus, the lower frequency one should be the longer one. That's the 350 Hertz one. Thus, the 350 Hertz pipe is the longer pipe. Okay. Maria blows air across one of her pipes, and it produces a third harmonic with a frequency of 762 Hertz. At the same time, her friend Sophie blows air across a similar pipe and also produces a third harmonic. They both hear a sound of 764 Hertz, which is the average of the two frequencies. The sound varies in loudness at a frequency of 4 Hertz. State the name of this phenomenon and explain how it causes Maria to hear a variation in loudness. All right, so this is about beats. So this is called beats. And what we need to explain here is that we have two similar frequency waves arriving at Maria's ear at the same time. They superpose and they interfere. Because of the slight difference in wavelength, they'll go in and out of phase, which means that they'll alternately constructively and destructively interfere, leading to loud followed by quiet followed by loud, and so forth. Okay, so let's try to summarize that efficiently here. So we've got two waves of similar frequency superpose at Maria's ear. Because of their different wavelengths, they will go in and out of phase. Go is a bit unscientific. Let's say they will be in and out of phase. Why don't we say like alternately or repeatedly or something like that? Because of their different wavelengths, they will be in and out of phase alternately, leading to alternating loud and, well, actually we've skipped a step here, alternating constructive and destructive interference. This results in alternating big, I'll say bracket loud, a big amplitude, let's just say big amplitude, and we'll call that loud, and small amplitude and quiet. So we have stated the name and we've explained how it causes Maria to hear a variation in loudness. Okay, calculate the length of Sophie's pipe. Okay, we have to dig up some information here. So we had two different frequencies. It's a third harmonic with a frequency of 762 in one pipe. And we have Sophie blowing across a similar pipe, also the third harmonic. And we don't know, this is a combined frequency. And we have a beat frequency of 4. Okay, so we can see that this is the frequency of one of them. This is the combined frequency, which should be the average of the two. 762, 764. The other one has to be 766, so that their average is 764. We also know that they need to be 4 hertz apart because that's the beat frequency. So there are two ways of finding this out. So we can say 764 is the average frequency. And whose was it that we knew? Maria. Maria's, this is hertz, pipe is 762 hertz. So 762 plus F Sophie over 2 must equal 764. So 2 times 764 minus 762 is equal to F Sophie, which is equal to 766 hertz. Okay, we probably didn't even need to do any working there, but I thought I'd just show it. There is, alternatively, the other way that you could find that, by the way, this is a very easy thing to find, but we know that the other frequency has to be 4 different to 762, so it has to be either 766 or 758. It's not 758 because the two have to have an average of 764. It must be above 762. Okay, oops, let's undo that. Why is it moving the background? Let me just move it like this. Okay, so we know what frequency Sophie's pipe must have, and so we can say we're trying to figure out the length of the pipe, so we need to find the wavelength, right? So lambda is equal to V over F, which is 343 over 766, which is let's get rid of this thing. 343 over 766. It's that long thing. 0.448 meters. This is only to 3 significant figures, but we'll use the unrounded number in our next calculation. And we know that for the third harmonic, we have to have 3/4 wavelengths in the pipe. So we know that lambda is going to be, well, it's going to be 4/3 of the length. Or we can just draw a little sketch here if we're at all unclear. So we know that we have to have 3/4 wavelengths here. If we divide this into 3, so we're going to have 1, 2, 3, 1, 2, 3, like that. So we know that the length here, L, has got to be equal to 3 lambda over 4. So that's 3 times 0.448 over 4. So we'll just go back here and go times 3 divided by 4, and we get 0.336 equals 0.336 meters. Cool, so that's the last of the questions in this one. I hope that all makes sense. Please let me know if you have any questions.